Okay, hi everyone. Sorry, it has been a few days since I originally sent you that stuff way back on, when was it? I think on Tuesday. And I do apologise for that. Obviously, it's been pretty crazy here with closing schools and no exams. So I do feel really bad, and I hope wherever you are doing your social distancing and it's not too crap. Anyway, so we need to look at kind of the last example, I think, in your notes. I think we've covered everything up until this point. Just for a quick recap, if you are, say, for example, if we're looking back up at this spinner question that we had the other day, to find the probability out of, say we spin the spinner 3 times, okay, to find the probability that it lands on, we'll say that it lands on white 2 times. Okay, we would do that firstly. Okay, we know it's binomial because we've got we got 2 options, white or not white. We are looking at white is our success. And when, I don't think I kind of talked about this too much the other day, for the probability of success, we always call that P. So our probability of success in this case would be 2/3. Okay, probability of failure is 1 minus P, and sometimes you'll see that referred to as Q. That's obviously 1/3. Okay, the number of trials we have, or the number of times we're going to do the experiment, that's N. So in this case, N equals 3. And our number of successes we're looking at, that's R, and so R would equal to 2. Okay, so when we're looking at the binomial distribution, we can draw out Pascal's triangles. We got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, so if we're looking at the number of times, if we take successes going from left to right, so this would be 3 successes. So if we look at where we've got 2 successes, okay, our probability where x equals 2 would be equal to 3, or NCR, times by P to the power of R times by Q, or 1 minus P to the power of N minus R. Okay, so that would then be 3 times by 2/3 to the power of 2 times by 1/3, and that would be 3 times by 4/9 times by 1/3. So that would be 12/27. Okay, that's our probability there. Okay, all right, now this is obviously a lot of work to go through and do this in hand. So I want to look at that last example again. We'll talk through it a little bit, and then I'm going to show you how you can do it on the calculator without having to mess around with all of this kind of crap here. Okay, so if we scroll down, our example is we're selecting a card at random from a pack of 52 cards. Now that's just telling you, whether you've got a standard deck of cards or not. That information is actually kind of irrelevant to the question. It's being repeated 16 times. Now this is important because that means your N value, your number of trials, is 16, and it's with replacement, and that's really important as well because if it's not a binomial distribution, unless the probabilities remain the same. So we want to calculate the probability that exactly 5 hearts occur. So this is the first one. So that would be where your R value is equal to 5. Right, now, if we're looking at hearts, the probability of picking out a heart is 1/4 because you've got 4 suits in the deck and only one of the hearts. And so that means your probability of failure is 3/4. Okay, so for this one, A, probability, we're looking at the probability where x equals 5 is equal to NCR times by P to the power of R times by Q to the power of N minus R. So that's going to be 16 choosing 5 times by 1/4, because that's your probability of success, to the power of 5, times by 3/4 to the power of 11. Okay. Now if we look at the calculator, we can chuck this in. So we've got NCR, I always forget that you got to do this bit first. So you got 16C5, okay, times by 1/4. Sorry, it's very slow doing this on the computer. You guys have already probably done it already. Oh, not squared. Sorry, no, it's to the power of 5 times by 3/4 That's why it's so slow, because you've got to be so specific about what buttons you're pressing, where, and how you're doing it. Anyway, to the power of 11. All right, so now if we chuck this in, that's going to give us that probability, which is 0.1801. Lovely, there it is. Now, I want to show you how you can work this out without having to muck around with any of this thing. So the calculators have the ability to do this calculation for you. It's in menu, so jump in there, and it's in number 7, which is that. That's what we call a normal distribution, but we're going to use one of the other types of distributions, the binomial one. Okay, but that's your distribution menu. So in 7, you'll see there it says binomial PD. Now, binomial PD refers to probability density. So when you want to find the probability of one single event, such as where x is equal to 5, you use PD. If you're looking at a greater than or a less than event, which is what we're going to do for B and C in this question, then you use binomial CD, and that's just the next one down if you use those arrow keys. Okay, but if we go up, number 4 is binomial PD. Okay, then we want to press 2 for variable, and it comes up with x, n, and p. Perfect. So x is 6. X is 5. That's what we're trying to find. Okay. Sorry, enter and it goes down. N is 16, okay, enter. And P, you can put in a quarter or 0.25, I'm going to put in. Okay, if we press enter again, okay, then you can see it comes up P 0.1081. Oh, that should actually have been a 2. Sorry, change that to a 2. All right, bad rounding on my part. Apologies. Okay, cool. So that's how you would do it on the calculator, so you don't have to go through and do all of that. If we look at part B, we're looking at most 8 hearts occurring. So that would be 0 hearts, 1 hearts, 2, all the way up until 8, which is the very, very most hearts that you could have occur. So we're looking at the probability that x was less than or equal to 8. Okay, and you could also write that as a probability that x is less than 9, but when we're using binomial CD on the calculator, we generally try and use less than or equal to, not less than. So try and make sure always that's equal to and less than, not the other way around. Okay, so from this, if we were going to work this out by hand, we would need to work out the probability where x equals 0, plus the probability where x equals 1, plus the probability where x equals 2, and etc, etc. And you can see there that's super time consuming and really irritating. Okay, something else to note is that your calculator cannot calculate greater than probabilities using cumulative density functions, okay? Only less than probabilities. So for this one, it's totally fine. But if you have a greater than or equal to, you're going to have to do something sneaky to be able to get it to work on the calculator, all right? So with this one though, we can work that out on here. So if we go back to that distribution menu, and now because we're looking at cumulative probabilities, the sum of those probabilities, then we go down to binomial CD, that's number 1. Okay, again, we're still using variable. Now we're looking at less than or equal to 8, so we can chuck 8 in there. The rest stays the same. And as you can imagine as well, this should be quite a high probability because we should expect that actually it would be quite statistically unlikely to pick out more than 8 hearts out of 16 cards. There's only 13 hearts in the deck. And so as you're adding on more and more and more, it's becoming less and less and less likely that you're going to pick out that many. Okay, so this should be quite a high probability. So again, we're going to go down. Okay, and there we end up with 0.9925. So again, yeah, super likely that is super likely that you pick out less than 8 hearts. If you did want to work out the probability that you picked out greater than 8 hearts though, all you would need to do is subtract this from 1. So the probability that x is greater than or equal to 8 is 1 minus 0.9925, okay, which is 0.0075. Okay, so nice and easy to work out. And this is what you're going to do on the calculator for the next bit. Okay, so for number C, we're looking at the probability that at least 3 hearts occur. So that's the probability where x is greater than or equal to 3. Okay, it's at least 3. 3 is the smallest, and we're looking at all the possible probabilities above 3. Okay, now when you're doing this, the calculator won't do greater than, but it will do less than. So the probability that x is less than or equal to c is the same as the probability of 1 minus the probability that x is less than or equal to 2. And I'll just kind of draw this out for you. I'm not going to draw out 16, okay, but if I just draw out 10, you should get the idea. Okay, so there's 10 numbers. Okay, these are your 10 cards you're picking out. Now, all of the probabilities of these add up to 1. So if you're looking at the probability that something's greater than or equal to 3, okay, you can work out, if you don't know what that is, you can work out that by saying that's 1 minus the leftover probabilities. Oh, and actually we should have had a 0 in there as well. There you go. 1 minus the probabilities of the lower values. Okay, and that 1 minus that will give you that middle bit there. Okay, so from here, I'll stick to red. We've got 1 minus the probability that x is less than or equal to 2. So again, we can use that CDF, binomial cumulative distribution in here. So binomial CD, okay, again, variable, and you're looking at where x is equal to 2, because we want that less than probability. Okay, enter, enter. Okay, we get 0.1971. So 1 minus 0.1971. Okay, gives you 0.8029. Okay, and there we're done. Alrighty, so that's pretty much all you guys missed out on the other day. I'll just quickly scroll down, just check there's nothing at the bottom there that we need to go through. No, that's it. Okay, cool. So that's all you missed out on. I'm going to send you guys all some questions to do on binomial probabilities. I just want to wrap your head around it, and I'll also resend the end of chapter prep. I'd like you to give that a go. I was thinking for Monday, if you can just focus on getting that done, and then on Wednesday I'll update you with what's going to happen for the rest of the week. Okay, all right, thanks very much. Hope you're having a great time. Okay, bye.